Ever get that feeling like you've been tricked? Like you thought you understood something perfectly, and then bam, a tiny detail changes everything.
Hmm.
That's what we're diving into today. A fresh look at Newton's first law of motion based on an article from Science Alert just last month.
Oh, wow.
You ready to have your mind blown?
I am always ready for that.
All right, so we're talking about the law that says an object at rest stays at rest, and an object in motion stays in motion at a constant speed and in a straight line unless acted upon by an outside force. We've all heard it a million times.
Yeah, pretty fundamental stuff.
So where's the trick?
Well, the trick lies in a single word in Newton's original Latin text,
Oh,
quatenus, which was translated into English as unless. Turns out a more accurate translation is insofar.
okay.
And that little change has some pretty big implications.
I'm intrigued. Break it down for me.
Okay.
What's the difference between unless and insofar in this context?
Sure, so the unless translation implies that an object's motion only changes if a force acts upon it. But insofar suggests that every change in motion, like speeding up, slowing down, changing direction, is directly caused by external forces.
Hmm.
It's a subtle shift, but it changes the entire emphasis of the law.
So instead of thinking about objects moving in a vacuum until something stops them, we need to recognize that forces are always at play.
Precisely.
That's interesting.
Think about a ball rolling on the ground.
Okay.
We all know it eventually stops.
Yeah.
But why? It's not like someone magically reached out and stopped it, right? It's because forces like friction and gravity are constantly acting on it, even if we don't always see them.
That makes a lot of sense.
Yeah.
But if this insofar interpretation is more accurate, why are we still taught the unless version? Why hasn't this come up before?
That is a fascinating question.
Yeah.
It seems that over centuries, the unless interpretation became so ingrained in our scientific understanding that it was rarely questioned. Plus, accessing original Latin texts wasn't exactly easy for everyone.
So a combination of tradition and limited access kind of bury this more accurate interpretation.
In a way, yes. It really makes you think about what other scientific truths we might be taking for granted simply because they've been repeated for so long.
It's like realizing that the map you've been using your whole life is slightly off.
Right.
It might still get you to your destination, but the journey might be a little different than you expected.
Exactly.
So how did Newton himself apply this insofar understanding of his first law?
Well, one of the most insightful examples he used was a spinning top.
Okay.
He pointed out that even though a top seems to spin on its own, it eventually slows down and falls over due to the force of friction from the air and the surface it's spinning on.
So even something as simple as a spinning top is constantly experiencing forces that are changing its motion.
Exactly. And what's really fascinating is that Newton used this example to illustrate a much bigger idea.
Oh.
That the same forces that govern the motion of everyday objects here on Earth
Uh-huh.
also govern the motion of celestial bodies like
Right.
planets and stars.
Wait, you're saying the forces that make a spinning top slow down are connected to how planets move? That's a pretty big leap.
It is, but it's a brilliant insight.
Wow.
Newton argued that planets don't just move in straight lines, their curved paths or orbits are the result of the constant force of gravity exerted by the sun.
Okay, I'm starting to see the connection.
Yeah.
So just like friction affects the top, gravity is constantly acting on the planets, pulling them into their orbits.
Precisely, and what's amazing is that Newton was able to connect these seemingly disparate phenomena, a spinning top on Earth and the movement of planets millions of miles away, using the same fundamental principle.
Wow.
His first law of motion interpreted with that crucial insofar.
This is definitely one of those deep dive moments where a tiny detail opens up a whole new understanding of a familiar concept, and it leaves us wondering what other scientific revelations are hidden in plain sight. So what's the biggest takeaway from our deep dive into Newton's first law?
I think the key takeaway is that we should never stop questioning, never stop exploring. Even the most established scientific truths can be challenged and refined, and sometimes a fresh perspective can lead to groundbreaking discoveries.
It's a call to action for all of us to stay curious, to keep asking why, and to never be afraid to challenge the status quo.
And who knows, maybe the next great scientific breakthrough will come from someone who dared to question a long-held assumption or to look at a familiar concept in a new light.
Maybe that someone is listening to this podcast right now.
Maybe.
If you've had any aha moments during our deep dive, we encourage you to share them in the comments below.
We'd also love to hear your suggestions for future deep dives. What other scientific mysteries are you curious about? Let us know, and we might just explore your question in an upcoming episode.
And that brings us to the end of another deep dive. We want to thank you for joining us on this fascinating exploration of Newton's first law and its unexpected makeover.
Until next time, stay curious, keep questioning, and never stop exploring the wonders of the universe.
If you enjoyed this episode, please like and subscribe to The Deep Dive for more fascinating explorations of complex topics. We'll see you next time.